We are now into section 3, the paragraph based questions. The section of paragraph based questions. Let's read the paragraph. It says, a heavy uniform rope of mass m equal to 8 kg and length L equal to 20 meter is hanging in a vertical plane with the help of two fixed supports at P and Q as shown in figure. Tangent drawn at the end of rope makes an angle theta equal to 37 degree with vertical. On the basis of above information, answer the following questions. And question 15 says tension at midpoint of rope is. We have been given the 4 options. We have to select the correct one. So what we do is we make use of symmetry. We draw the free body diagram, applies laws of motion, the condition for equilibrium. So if I draw, its weight is here mg and the value of mg is 80 Newton because 8 into 10, it's 80 Newton. Let's say tension at both these points, they will be equal by symmetry in magnitude. So if this is, let's call it T1, this is also T1, and with vertical this makes angle theta equal to 37 degree. That's been given to us. Theta is 37 degree. So first we can find easily T1 by applying the equilibrium in the vertical direction, which means 2T1 cos 37 degree equals 80 Newton, or T1 itself is 40 by 4 by 5. That means it is 50 Newton. To find the tension at midpoint, we need to draw another FBD. We will cut the rope at the center and we can look at either half. Let's take the left half of the rope. So for the left half, here is tension T2, or let's call it TC, tension at the center. Here it's going to be T1, and the weight of this part will be half of this, that is 40 Newton. We need to only concentrate on equilibrium in the horizontal direction. So in the horizontal direction, there are two forces, TC and component of T1. We look at the equilibrium in the horizontal direction. In the horizontal direction, the component of T1 is T1 sine 37 degree, and there is TC here. So the equation is T1 sine 37 degree equals TC. We have the value of T1. So if you put T1 is 50 Newton and sine 37 degree is 3 by 5 equals TC. The value of TC turns out to be equal to 30 Newton, which is matching with option C. So option C is correct. Let's go to the next question of this paragraph. The question 16 says radius of curvature at the lowest point of rope is. Now to find the radius of curvature at the lowest point of the rope, what we do is we cut a small segment, very small segment at the lowest point, and let us magnify it, right? So let's call these points A and B. Let's magnify and draw an enlarged view. So this is A and this is B. Let's say this is the center of curvature for this part, C. Now this is a very small segment, so we can call this angle as d theta, and we draw its FBD again. The tension can be taken as same as tension TC that we found, that means tension at the middle. So here it is TC, here also it is TC, and weight of this part will be the length multiplied by linear density multiplied by G. The length itself is, if the radius is R here, then this length is R d theta. R d theta is length into lambda into G. Lambda is the linear density. Again, if we look at the vertical equilibrium of this segment, we get the expression 2Tc sine d theta by 2, because if we draw a vertical line, this angle is d theta by 2. So this angle is also d theta by 2. So the vertical component is Tc sine d theta by 2, and by symmetry the other part also gives vertically Tc sine d theta by 2. So we have 2 Tc sine d theta by 2 equals R d theta lambda into G. Now obviously d theta is extremely small, so simplifying we get Tc equals R lambda G. Lambda is mass, which is 8 kg divided by 20 meter, into G, whose value in SI units is 10. The value of Tc we have found to be 30. So we get R equals 30 into 20 divided by 8 into 10. So this is 2, this is 4, 30 by 4 meter or 15 by 2 meter. That's the value of radius at the lowest point of the rope, which is matching with option B. So option B is correct. Let's go to the next question now. This again is a paragraph based question. Let's read the paragraph. It says, a river is flowing in horizontal plane with velocity v0. A swimmer at one bank of river wants to cross the river. If speed of swimmer in still water varies linearly from v0 to 2v0 from one bank to the other, then answer the following. Minimum time in which swimmer can cross the river is equal to. Well, so the key point here is that the speed of the swimmer with respect to river is not constant. It is varying. It's varying from v0 to 2v0. And for the minimum time, the velocity of the swimmer with respect to the river always has to be perpendicular to the river. Okay. So using these two concepts, we can write now. So Vy for the swimmer will be varying from v0 to 2v0. That means we can write it as v0 plus v0 by d into y. If we put y equal to 0, we get this as v0. And if we put y equal to d, we get it as 2v0. So this is the expression for the y component of the velocity of swimmer if he is crossing the river in the shortest time. So that means we can say dy by dt equals v0 into 1 plus y by d. By cross multiplying, we can write dy by v0 into 1 plus y by d equals dt. Let's integrate. T goes from 0 to t and y goes from 0 to d. Integrating, we get 1 by v0 ln 1 plus y upon d, and the coefficient of y is 1 by d, so we divide by 1 by d, so d will come in the numerator now. The limits are 0 to d equals t. Further simplifying, we get d by v0 into ln 2 minus ln 1, ln 1 will be 0, so d by v0 ln 2 equals t. Let's look at the options. It's clearly matching with option C, so option C is correct. Let us go to the next question now. Question 18 says, if swimmer crosses the river in minimum time, then equation of trajectory of swimmer will be, well, we have been given these 4 options. So basically we have to find the expression for equation of trajectory. Basically we have to find the equation of trajectory of the swimmer. The coordinate axes have been specified here already. So to find the equation of trajectory, we find expression for y as a function of t and expression for x as a function of t. So for finding y, we again write vy or dy by dt. Like in the previous question, we write this expression again. Like in the previous question, we write this expression again. Dy by dt equals v0 plus v0 upon d into y, and which means we have dy upon v0 into 1 plus y by d equals dt. So we integrate. Now the lower limit again is 0 for y. The upper limit is y only because we want an expression for y. So integrating, we get 1 by v0 ln 1 plus y by d. The limit is from 0 to y, and the coefficient of y is 1 by d, so we divide by 1 by t, so d comes here, so we can put this as d, and on the right hand side is t. After putting the limits, we get d upon v0 ln 1 plus y by d equals t, or ln 1 plus y by d equals v0 t upon d. Further simplifying, we get it as 1 plus y by d equals e to the power v naught t upon d. That means y equals e to the power v naught t upon d minus 1 into capital D. Let's look at the expression for x now. Expression for x is very straightforward, very simple. It is simply v naught into t. So we can replace t as x by v naught in the expression for y and we get the equation of trajectory. So if you put t equal to x by v naught, we get y equals e to the power v naught by d into x by v naught minus 1 into d, or simply y equals d times e to the power x by d minus 1. Let's look at the options. It is clearly matching with option A, so option A is correct. Other options are obviously wrong. Hope you have found this helpful. Thanks for watching, and I wish you all the very best for your preparations and the coming examinations. Bye for now.